1. So I think time is up, and today we will have 4 talks. Let me double check if the speakers are around. So we have Professor Chin.
Yes, okay.
Welcome. Professor Erkan.
Yes.
Nice to meet you. Professor Mandiha. Okay. Fine, last one is Professor. Okay, so according to the schedule, every speaker will be allocated 20 minutes.
Yes. Great.
So they pass this stuff to me.
Okay.
So I show you the kind of reminder. Okay, so let's start first.
Okay. Thanks for coming. What I'm going to present today is a problem-based learning approach. Okay, for Martronics. It's Martronics and applications for marine informatics course. Okay, so my name is Dr. Chin. I'm from Ieee University in Singapore. Okay, so basically what I'm going to present today is first I'll go through introductions, and followed by some brief description of the marine informatics course that we done in our marine these engineering courses, and some description about the problem-based learning, what is it, and discussion followed by conclusions. Okay, so basically the goal of this paper is to just to illustrate a proposed method of using modeling and simulations, alright, of the surface vessel, right, for the problem-based learning projects, okay, on the marine informatics course. Right, so this is the course that we conducted our bachelor degree in marine engineering. Okay, so in Ieee University in Singapore, this course will provide students with some very extensive introductions to very common use computer software such as the MATLAB, LabVIEW, and Pro Engineering. Right, and but we feel that the understanding of how the marine informatics course relates to practical applications are not really experienced by the students. Okay, so that's the reason, and we also find that the students do not seem to be very active, okay, and motivated during the laboratory sessions. Okay, that's before the problem-based learning approach. Okay, some students are actually unable to understand or complete the project within the allocated time frame, okay, which I will tell you what's the time frame. And we also, as instructors, we find it very difficult to teach this multidisciplinary subject because they come from a very different background and interest. Okay, and most of the students are quite weak, okay, in the computer-aided programming and techniques. All right, so to circumvent these problems, we propose a PPL approach, okay, on the marine informatics projects, okay, which we use to substitute the formal assessment methods that uses just a group assignment. All right, and we find that one of the good typical marine systems that we can use is the surface drilling vessel. All right, and why we select this is a most common type of marine systems. Alright, and it's not so complicated for students, okay, to work on, and it's very nice applications, okay, which may not necessarily present this entire field. Alright, so the proposed PBL project enables the student to work as a group, right, to solve the problem, and hence encourage them to develop some of the active learning, alright, because since they're in the groups, they also will experience the team participations, some work responsibility, and resource finding skills, okay, during the course of the projects. Okay, just to give you a brief overall view, a very brief one, okay, what is actually the PPL? Okay, for the history, it was basically implemented at the McMaster University in 1969. All right, and it's basically meant for the medical school, and almost 80% of it has been used in the medical school, and that slowly expand to many other fields, right? Okay, and this PPL is instructional methods, all right, that challenge the student to learn, all right. And basically, they have to work cooperatively in groups to seek solutions to the real world problems. Okay, for this case, is the surface drilling vessel. Okay, one of the primary features of PPLs is that this project is student-centered. Okay, so we will actually rely on the students. Okay, and the objective of which are, okay, so at least partly we let the students, find their own solutions and with some guidance from the facilitators. Alright, so we place partial or explicit responsibility on the students to shoulder their own learning and hence develop independence or inter-interdependent learning and brainstorming skills. Right, and the student will be able to take some responsibility for their own learning, okay, which what most of the traditional methods don't have this. Okay, and we also PBL serve to teach content, right, by not just presenting the student with the real world challenge. Okay, they also teach them how to model some of the simulations of the surface drilling vessel, okay, which they will encounter, okay, once they graduated and work in the design office of the shipyard. Okay, so to give you some description about this marine informatics course, which after I've briefly went through what is PBL. Alright, this is the course that's conducted in the stage 2 of the marine engineering degree program. Alright, and the aim of this course will include to introduce 3-dimensional solid modeling practice using ProE, and then we try to develop some skill in the algorithm developments or programming in a high level language such as the MATLAB or LabVIEWs, right? So that we expose the student in some of the CAD software. Okay, and they have to complete the course in 12 weeks, alright, or 1 semester, and they are divided into basically three groups, alright. So 12 weeks and 3 groups, so they take turns, okay, to perform MATLAB, LabVIEW, ProE, alright, and they just change over. Alright, so they have to complete this in 12 weeks time. So by the end of 12 weeks, they're supposed to have completed MATLAB, LabVIEW, and ProE. Alright, so this course, there's around 100 students, okay, which will attend these modules. Okay, so how we conduct this PBL, alright, so we basically allow students to have the chance to experience different roles, okay, during their group projects. Alright, so they are either a leader or they are a member, so they change the role during the process. So so they are the team leader, they are the secretary or just the observer, and maybe of course a member of the groups. Alright, and they are responsible to coordinate the work and also the time schedule between the team, right? And the tasks they need to do, alright, they have to first write down the problem statements, alright, and meaning that they must understand what are the problems that they try to solve, alright, for this case the drilling vessel, right, the dynamic positioning of the drilling vessel, okay, and they also need to come up with some of the ways, alright, the discovery journals, how what are the current methods that are being used, alright, to solve these dynamic positioning problems. Okay, and we will have some quiz, alright, some quiz for them to fill out, alright, to complete, and we also encourage some of the peer teaching, alright, meaning that one student can teach maybe the another students, right, and also we have peer evaluations, alright, we want to know that how well each of the student or the member in the team is working together. Okay, we also have some reflective journals, alright, the reflective journals for the students to reflect on what they have learned, alright, during the past 3 weeks to 4 weeks. Okay, and they also can provide us with some project feedbacks, and at the same time the staff or the instructors can provide some feedback to the students. And at the end they have to do some project presentation, alright, they have to present what they have done, okay, like modeling and simulation of the drilling vessels, okay, in the groups, alright. So each of the students within the group have to play a part in the presentations. Okay, so basically these are the breakdowns for the 4 weeks, okay, which I have just explained what is meant by the PS, which is the problem statements. You know? And the second week will be, or the first week, you have to do some model of the vessel dynamics, right, and to model some of the external disturbance acting on the vessel, okay, which will be included during the second weeks, and some of the essential modeling techniques in MATLAB and Simulink. Okay, and finally they have to do some simulation and this analysis of the vessel performance in terms of the position and the velocities, okay, under this disturbance. So these are the tasks that they have to do within 4 weeks, okay, for each group of the students. Okay, so in a oral summary, okay, this is what I try to say is that basically they will start with the problem statements, discovery journals, and so on. Alright, and we actually give some percentage, okay, to each of these tasks. Alright, so for example, the problem statement, the group have 10%. Alright, and we also consider on some of the individuals, alright, the performance. Okay, we do not want to have any free riders. Okay, we also want to take into the account, okay, of whether each member have contribute. So this will be mainly on the discovery journals and peer teaching quiz. Alright, so group will have some percentage that will be attached to it. Alright, so total will be 100%. Okay, because this is the full project work. Okay. Alright, so in the end of the 4 weeks or total of 12 weeks, which every group have actually experienced the MATLAB, BlackView, and ProE. Okay, so they will just hopefully that they have some desired outcomes. Okay, like some skills that you want them to actually have, like chairperson skills for those leader, which they actually take among themselves, and the brainstorming skill, alright, the team working skill, alright, and some of the oral or communication skills that they should have, right? So these are some of the skill set that they will gain or they will experience during the total of 12 weeks, okay, or 4 weeks each for different software. Alright, but it might be difficult for them to have all these skills, but just to have the chance for them to achieve so more experience. Alright, so basically, okay, what we think is that to manage, okay, the time and the work distribution among the group members is a bit of quite challenging, because we only have four weeks for one software. Okay, and so we actually rely quite a lot on the student, give a lot of freedoms for the students, okay, on the type of projects, but they have to be in the specific areas that we have mentioned, okay, which is the modeling estimation of the marine surface vessel. Okay, and we find that by doing so, we put a lot of responsibility to the student, and the student will be more of the self-motivated, okay, rather than self-driven by the lecturers or the instructors. Okay, and besides that, we also find that we also give opportunities for the instructors to learn something from the students. All right, because we might not know everything, so sometimes it's a two-way communications. Okay, as instructors, we also gain something from the students. All right, and we also find that with different instructors handling different group of students, we tend to also work together as a group as well. Besides the students who form the groups, I think for instructors, why we also be able to have more close relationships and understandings, okay, of the areas. All right, and also we feel that the adaptability of these PBL structures, okay, it can be adapted to many subjects, not only the marine informatics tools, which is basically talking about the modeling and simulation of the marine surface vessel. Right. Okay, so we find that PBL approach is proposed, okay, for this teaching, okay, for the marine informatics subjects, right? And by using PBL methods on the modeling and simulations of the surface drilling methods, it provide a very good hands-on sort of experience, okay, for the students to acquire skills, right, in the modeling and simulation aspect, okay, of a Martronics system, which is the marine Martronics systems. Okay, and but I think that we need to put more credits to these activities because there's a lot of preparation times, like to come up with standard forms for the problem solving, the peer teaching or peer quiz, alright, all the forms that have to come up with, whether it's electronically or hard copies. I think a lot of work has to be done. So I think the school must give us more credits, okay, both the student and the lecturers or the instructors. Okay, and I believe that the very general guideline is that the instructor need to be trained, alright, in the PPL, alright, prior to the implementations, alright, so that to just make sure that they are in a very consistent kind of delivery to the students, and the way that we want them to do have to be consistent, alright, and we find that not only for our case, for our universities, or not even just for these marine informatics courses, I think that we can also do a further research or efforts to integrate the PPL to other subjects, or even doing this electronically rather than in hard copies or manually. Alright, so with that I just like to conclude my presentation, a very short presentation. Okay, I'll open up to any questions that you have.
So we have one or two questions.
Yes, definitely.
So
yeah.
I have interest about your peer evaluation scheme. So
Yeah.
how actually you implemented it?
Alright. So basically, what we have intend to do is that we give the student, each student, a form to fill out. Okay, and this form will consist of what is basically their contribution, okay, in percentage of certain tasks. Alright, and we collect all the forms from each individual students, and then we this is done manually, but right, it has to be done electronically or using some sort of these algorithms. So, but we done it very manually, and we take this average, okay, of each of the student contributions.
Is it enormous or is no?
Oh no, it's actually enormous. We do not let the student know the name, but we will actually know the student name. Okay, so the student have to do, let's say there's 4 students, alright,
okay.
A, B, C, D. So the A will do the B, C, and D.
Okay.
Alright, then the B will do the A, C, D.
Or will like A evaluate B, C, D?
Yes.
Will B, C, D knows A comments?
Oh no, they will not know.
But will each particular student knows the comments from the peers?
They will not know because we keep it to the instructors. Alright, so that we make it a very such a kind of circumstances that no one will know, okay, what is their peers commenting on.
Does it work around for your case?
It's not very consistent, alright, because we find that it might not be because some of the friend might say that no, you put me in a very heavy contribution at this part and that part, which sometimes they gang up, and this might not reflect the true contributions. Okay, that will be more towards their own friendships. Right, so
some students basically they team up and cooperate and just be very high on everybody.
I think most of them give quite high to each of them. Yes, yeah, they're very cooperative case, and I think this is something that we have to look into a more better way of doing, because most of the students give a very high contribution, okay, to their friends.
No, this scheme is very popular.
Yes, correct.
In the US.
Yes.
Yeah. I once implemented in Hong Kong, but the result is not good.
Yeah. So I think we need some form of algorithms. I think we have to put in some more effort into doing this, the peer evaluation. Yes.
Any more questions? If no, let's thanks Professor.
Okay.
So the second talk is by Professor